So today we are going to look at design of goods and services briefly, very briefly. I'm not going, I have no intention. We have this week and next week, okay? So I don't have the intention of, trying to, I always say this, I'm not trying to make you an expert in, these specific areas, but I appreciate if you can have a good overview, okay, understanding. So this topic, the book gives an example of Regal Marine. Regal Marine is a company that actually produces luxury boats, okay, luxury boats. So in terms of their product strategy, okay. But we can look at product design in all other kinds of companies, Huawei or even Samsung. Okay, you can refer to all this, look at all these kinds of companies. So we're going to look at goods and services selection. Remember that when we want to ensure that operations are going to be implemented efficiently, so we must understand what are the goods, what are the products that we produce, as well as the services. So goods and services selection. And there is a process for generating new products, because we need to ensure that we reach the market according to our plan. Okay, we cannot be introducing product behind our competitor, because competition. For example, Samsung and iPhone always have introduction of new product very close. Okay, and this is what we call as product development. We look at some of the issues for product design and product development continuum or processes or steps. There are methods of defining a product, because when we talk about product design, we need to actually have a system for defining the product in terms of the product structure and so on. And in order for us to make the product, then we need to develop documents for production. We need to have a system for documenting for production. Okay, and not only that, because that's covering for product design, service also must be designed. Okay, you must design services, and it can also be documented as well. Application of design trees to product design, and the transition to production means whenever you have designed and developed the product, so we need to actually make sure we be able to produce it. And the transition towards production is smooth, because in design you only make sample. You only make a few. You have pre-production. You make 10 samples or 100 samples. But in production, you're going to actually produce more than the samples that you have tested. Okay, you're going to mass produce it, because there is going to be economies of scales, right? Transition to production. So these are the things that we're going to cover: define product life cycle, describe product development system. There is a method which is used in design. Okay, it is the house of quality, or the so-called quality function deployment. Okay, this is developed by Japanese, QFD, and it's being used by some of the big companies, major companies. And we will also look at how time-based competition is implemented by operation managers, and the rest of these things. Okay, so describe how products are defined by operation management, because we need to make sure operations will be able to make and make the products. Of course, marketing will be able to sell the products. And we want to describe the documents needed for production. I mentioned just now already, because in design it's only design drawing. So how are we going to transfer that to production? In terms of services, okay, because services, customer and producer is is engaged instant at the same time. Okay, for example, now I'm imparting my education service to all of you. Okay, the consumption of the what you call service is instantaneous. I'm delivering the service and you are getting the service. So it's instantaneous. So customer participation is very important actually in services. Okay, we have time. Okay, we'll look at that, but probably not in much decision trees. So this is Regal Marine. If you see the background, it's actually craft, not craft, luxury boats. Okay, luxury boats. And what is important when they develop new products? Okay, they use three-dimensional computer-aided system, computer-aided design system. So they have CAD system, and this reduce product development time. And today there's a lot of automation in design. Reduce problems with tooling, reduce problems in production, because we have already they have already incorporate and consider a lot of things during design stage. Okay, and they have assembly line production. You can see the assembly line. It's actually this assembly line. Okay. Sorry, excuse me. And they have their IT system. So when you talk about goods and services, so companies must try and design or even select goods. Okay, select goods and services. Organizations exist to provide goods and services to society. Why we exist? Because there is a service, there is a product that we produce, and of course, the key to success is, of course, great products. Great product means product that meets the customers in terms of design, in terms of usability, in terms of quality, and so on. Okay, and companies focus on core products. That means you do not produce, like for example, forefront manufacturing. They only produce doors. Okay? They don't want to produce any other, because their specialty and their capability, right? So you have a core product that actually produce. Customers buy satisfaction, not just a physical good or particular service. Meaning that customers look for not only the ability of just getting the product, very nice color, very nice shape, but the ability for it to meet his requirements. Okay, using it. Okay, is it functioning very well? For example, you buy a new car, do you cause problems? So customers buy satisfaction. They don't just just look for the the outer appearance and so on. Okay, so fundamental to any organization strategy is actually in terms of goods and services selection. It is fundamental. What kind of products are you going to produce? What are you going to design? So before you can produce, you need to design. And of course, it depends on your capability and ability. So goods and services are the basis of any organization existence, and all products and goods have limited life cycle and predictable. Okay, there's a predictable life cycle. So limited and predictable cycle. Therefore, you require constant looking for new product, designing new products, developing new products, because new products will generate substantial revenue, right? Once a product life cycle has reached the end of life, okay, end of life, then you need to find new products, okay, replacement products. Right. So the industry leader in terms of percent of sales from new products, you can see that it hold a big share, okay, a big share of market sales from new products. Okay, the higher the percentage of sales from the last year, the more likely the firm is to be a leader. So that's why companies who are innovative. Innovative means you will always find new products, new technology, new methods, new appearance, and so on. Okay, we can refer to big companies, not only in electronics, in automotive, and so on. So the objective of product design, of course, it involves product decision. Basically, it is a product decision to meet our operations strategy. Okay, the objective of product decision is to develop, implement a product strategy that meets the demand of the marketplace with a competitive advantage, meaning that we will be able to produce it at a high volume, meets our revenue, then we can survive. So these are the common product strategy options that companies pursue. Okay, you have heard of this before, right? In strategic management, you will see that these are common strategies. Whether the product is going to use a differentiation strategy. Differentiation means I am unique from the other products in terms of, for example, my quality is excellent. I don't have any complaints for the customers. Okay, or for example, this is also partly different. But differentiation is unique. What is it unique between, for example, Toyota and Nissan? What's the unique difference? Or even Mazda. You can compare Mazda and Toyota, whichever you like. If you like Mazda, you tell me what's different between Mazda and Toyota. Anyone? Differentiation. If they really their product strategy is differentiation. Anyone has heard before? Mazda. Mazda is known for Kansei engineering. Kansei Nihongo yo. Feeling. That's why Mazda cars are very, very robust, very, they're nice to drive. Toyota is reliability, high quality, cheap, cheaper than Mazda, cheaper than, I don't know in Japan, but that is the the differentiation strategy. Okay, even hospitals also can. This is hospital. Okay, low cost strategy, product low cost strategy. If you look at vaccines today, which is the cheapest vaccine? It doesn't mean the vaccine is no good. COVID vaccine, cheapest COVID vaccine. There's Pfizer, there is Moderna, there is AstraZeneca, there is Sinopharm, there is Indian. I also do not know the brand, the name. China produces one of the cheapest vaccine today, correct? Cheaper than Pfizer, because the strategy is low cost. And they use from, what they call, different methods and different, technologies. So low cost strategy. You can go for that. Or rapid response. Okay, Toyota is rapid response. Sorry. Okay, Toyota is their strategy is rapid response. So different product strategy that is required. So if you are rapid response, for example, Toyota, when you manufacture, so you think about operations. So the operations must be efficient. That's why they have just-in-time system, Toyota production system. They don't keep too much stock. But today, is the theory is not working today because of COVID. COVID have destroyed GIT. Okay, GIT is not functioning well in COVID. Anyway, product strategy. You have this now. So product life cycles can be anywhere between a few days to decades. Time, in terms of time, a few days to decades. And of course, the operation function must be able to introduce new products successfully. But if they have old products and new products, they must keep both machines, both machines that produce old products and new machines that produce the new products. Okay, so then there must be balance. Anyway, all products have life cycle. You have seen this. I think I've shown this during forecasting last week about the need for you to forecast throughout the life cycle of the product, in term, especially on demand. But in terms of new product development, you can see that the cost of development and production is going to increase during the introduction stage of any product. Okay, any product, it will take, like, for example, if car industry, probably 1 year to 2 years, not even 1 year to 2 years, okay, maybe 1 year. Introduce, and then growth, maturity, and then decline. No more needed by the industry. For example, if you have seen the development of storage devices for for computing. Now we have this so-called pen drive. What do you call in Japanese? Nihongo wa nan desu ka? Correct. Pen drive de shou. Pen drive. Okay, pen drive. Mukashi wa, okay, this is also storage device, floppy disk. Okay, so 10 years, 20 years ago, 5.5 inch, then 3 inch. Okay. So that is decline. Okay, decline, no more use. When I was small, there is typewriter. You know typewriter? Typewriter. You also do not know typewriter. Sony Walkman still must know. Sony Walkman. Mo ima arimasu ka? Mo aru? Mo very small, very small. iPod. We have handphone. Iranai Walkman. So that is the all products. They will incur this cost of development increases during the introduction, growth, then they will actually decline. So you need to cover that with sales and sales revenue. Okay, so this is the cash flow in terms of product life cycle. It will come to the decline stage. And okay, this is what we call as the cash flow, negative cash flow and positive net revenue. Of course, you will, before you start losing a lot of money, so you need new product, new model, new design. Okay, so that is what is happening. So this is okay, in the more detailed description for the life cycle and strategy. The introduction phase, the fine-tuning of the product needs additional expenses, research, product development, process modification, and supplier development. So these new suppliers, because or even new products, new component, new technology, new battery, hybrid battery. So battery becoming smaller. So you need to actually develop the supplier. Okay. So you will go to the growth phase. The growth phase, product design becomes stabilized because you already know the problems of the new product, and your forecasting will become better. Not to become better. You need effective forecasting, because in the growth stage, you need to always think about capacity of the ability to produce. If suddenly the capacity needs to be double, meaning the demand increase, so you need to increase the machines. If you don't increase the machine, you're going to lose market share. Competitor will, eat up your market share, take your market share. Okay, so adding or enhancing capacity may be necessary. So operations will think about how to increase capacity during growth stage. Yeah? And of course, maturity stage, competitors, there are already competitors, high volume innovative production may be needed. You need the production to be innovative. Automation, new robots, new equipment, and you need to control costs, improve cost control. Reduction in options mean you reduce the different models that you have. For example, suddenly you have product lines. You have 10 product lines during the growth, but maturity, you reduce it to half, for example, 5 models only. Why? Because some of them will probably have small demand. Small demand, you can, let your competitor take that demand. So that's called paring down. Paring down means reduce the product lines. And of course, when you reach your decline phase, that means the demand is low. So you need to, think about terminating the product, terminate offering. Some companies like Nokia, because Nokia failed because they did not terminate their, what they call, people are moving into Android. Companies moving to Android, but didn't. They use still the operating system, old operating system. So they lose, and they cannot. Even today, Nokia is no more famous already. I remember 15 years ago, Nokia handphones. Nokia handphones? Nokia. Not famous in Japan. Samsung is a new brand. Samsung handphone. It's new brand. It's not. They came after Nokia. Okay. There was Ericsson. There was Motorola. If you study the difference, you will see. Right. Okay. This is the product lifecycle cost in terms of that you need to incur. This is cost incurred throughout the product lifecycle, from design until disposal. Okay, manufacturing. This is just a concept. Okay, concept. Anyway, so you must ensure that whatever cost that you have invested into developing new products are going to be recovered. Because some companies, your product become expensive when you cannot recover the cost that you, the money that you spend trying to develop the product, and also of course manufacturing the product. This line, what it means is this blue line, ease of change. Ease of change means how easy is it to change the design of the product as we go along this time. Earlier, it's easier to change. Okay, you can change the material, you can change the shape. But once you have already all the machines or the equipment, it's going to be much difficult. But of course, the percent of total cost is reduced because you are not going to change a lot anymore. Okay, the amount of changes that you do is highest during the early stage of any product design. Okay. Right. Companies need to understand which product that they need to actually develop. Okay. So this is a kind of analysis, product by value analysis. You want to look at which particular product that not only design and develop, but also they will determine in terms of your manufacturing decisions, whether you want to produce that product or not. Okay. So how do you do this analysis? So this is, you list the product in descending order of their individual dollar contribution to the firm, to the company. You list the total annual dollar contribution. Then you see which one gives you the, the greatest, and you focus on that. Okay. So this can also be decision on which product that you don't want to produce anymore, or you don't want to be involved in the development. Okay. So it will help management evaluate alternative strategies when you do this product by value analysis. Okay. Okay, that's only a concept that you need to just be aware of. Okay. Now, when we generate new products, why companies generate new products? Why are new products being generated? Because of the changes in technology, because of the needs of the customers, because of, there are many reasons. Okay. So when you generate new products, you need to understand the customer. You must do, that's why companies do market survey. They ask questions from the customers. What kind of, what kind of product that you think you want, okay, that you want today. What kind of product that you think there is, I hope there is this device. Okay, anyone, what kind of, gadgets, any ideas, any suggestions? Yu Hong, any suggestions?
I want a kind of machine that can remove my makeup.
Okay, very good. Okay, machine remove. Oh, okay. You know what you want, Yuma?
Yes. I want some machines to clean up my room.
Oh, machine to clean up room. Okay. Anyone else? Yusuke? Or software? No, okay. Who else? Who else can you want? It's so many things. You can have so many things. Shota, what do you want? What does the customer want? Chen, what do you want? What product you want that is not available, or existing one that you need improvement?
I want to some machine to clean my clothes.
I want a machine that can fold clothes. Folding clothes. Folding clothes. When after your laundry, it's so difficult to folding the clothes. Some people don't fold. Fold. Folding. So just put it aside. So I need a folding machine, folding clothes machine. Okay, Yule, what do you want? All of you want machines.
Machine. Automatic machine.
Again?
Automatic machine.
Acquisition.
Shampoo.
Yeah, automatic shampoo machine.
Yeah, help me wash hair.
Okay.
It's a difficult thing.
That's a good idea, actually. That's a good idea. Okay. Because yeah. Okay. So there is always need. Okay, there is always need for new things, and so the producers must understand the customers, right? Okay, because of economic change, because of sociological and demographic demographic changes. What about old people? What is happening to the older, people who are getting older? They need robots to take care of them today. So they have assistants. Okay, and all these things, okay, are actually not actually it demands new product, but when you generate new product, you need to understand this as well. You need to understand the customer, you need to understand the economy, you need to understand market practice, professional standards, suppliers, and so on. So what is the this is very engineering, okay? But don't worry, at least you are in an MBA program. You know how the people in engineering and also in operations develop products. You can have the same language, okay? So when you develop product, you will start with concepts. Concepts, okay? Concept. For example, when Isuzu Piazza is a kind of Isuzu Piazza is a kind of car in late 80s. So the concept was coming from egg, tamago. So tamago concept become a car. Okay, mini car. They say coming from this. There is this, basketball shoes, basketball high heel shoes, basketball. So they use this. I know a lot about cars because cars. So concept, start from concept, then feasibility. Is it feasible? Can you make that shape? For example, some shapes are very difficult to make. In construction industry, architects, they like to design buildings which are so much awkward in shape. Okay. In Kuala Lumpur, there is this building which actually looks like this. It's a building, small at the top. Building, it's a building. It's like it's our privilege fund. So customer requirements, and then it will move to functional requirements. So the customer requirement will be translated into functional specifications, and then product specification. You need to do design review. You need to test the market, evaluation. Okay. So the scope for design and engineering teams is here. So this is. Are you seeing the video?
Yes.
Okay. If you see this is actually a clay model. Have you ever heard the word clay model? This is a clay model of, a full-size clay model. During design of cars, they actually come up with a clay model. This is clay model. Okay. To sample, it's like a sample, but not the mass-produced cars. So when they want to produce it in a large quantity, then they replicate this. They need tools for making this. But during the design stage, this is what happened. Okay, right? So these are it's not easy job. Okay, it's a difficult job. But anyway, product and you must be on top of things, because competitors are always moving forward, right? You need to compete, right? So this is a very competitive industry, same as in new product development in handphones, also in smartphones. It's the same thing. Okay, same situation. Okay, let me just okay, we were talking about okay, product development stages, and these are the main. We need probably a product development stage, which is actually a system, okay, system for developing products. And there is a tool or a method which is called quality function deployment. Okay, it is a method in which you want to, it's a process for determining customer requirements, and then you translate that into technical requirements and your engineering specifications. Okay, so what it does is actually you identify the customer wants, and then you identify how you can how you are going to satisfy these so-called wants. Okay, it's not needs yet, it's just wants. Okay, and how to satisfy that, or how to fulfill that, and you relate customer wants to product house. How can we achieve the demand or the things that customer wants, and you identify relationship, you develop customer ratings, important ratings, and you evaluate competing products. That means you try to see whether the characteristics of your product that you're going to design, or you improve the design, is going to meet the customer's requirements or not. Okay, so basically, if we can translate the customer wants into our technical attributes, that means in terms of specifications, then you can can compete with your competitors. So it is also called the house of quality. So basically, don't worry about the details yet. This actually it is a process of, it's a team effort. Number one, it is not just one person, it is a team effort, whereby they will do a assessment of what the customer wants, and they give ratings, ranking. For example, if there is 5 different, what kind of toothbrush do you want? I want a toothbrush which is actually ergonomically designed, easy to hold. The brush is soft. So these are these are things that the customer wants, and you give ratings, right? And you need to identify how to meet these wants. Okay, so this is what, this is how, and you have a relationship matrix which relates the wants and hows, and you do the competitive assessment with your competitors or similar products produced by other people, other companies. Yeah? And you can, for each different kind of how you can actually determine the target values and the technical evaluation, and you can see the interrelationship. Just a simple example. This is a simple example. Your team has been given the responsibility to design a new camera. Very simple. It's not the detail, characteristics, but just a simple example. So you want to construct the house of quality. So what we do is we get the so-called customer wants in terms of, they say, okay, it must be lightweight, easy to use, reliable, and so on. Okay. And you give this rating. So this is the most important, number 1, number 2, number 3, number 4, number 5. Or 5 is the highest. Okay, 5 is the highest, then this is of course the most important. This is the less important. So 5 is the highest, reliability. So this becomes this part. Okay, so it becomes what the customer wants. And so what the company do is the design team will determine in terms of technically how we are going to actually fulfill that requirement. For example, low electricity requirement, low energy basically. We are going to use components making from aluminum because it's light, autofocus, auto exposure, high, and so on. Okay, so that becomes our internal company's house. Okay. Then from there, what you do is you find the relationship metric, meaning what is the relationship between lightweight and, for example, the aluminum component. Obviously, it's going to be high relationship because you're going to reduce the weight. Okay, easy to use. So it becomes a relationship between the what and the how. But of course, this will be done by the team, the engineers and the marketing people and the people who have knowledge about the product. So they put it inside there, the relationship matrix. And there are also relationship between the things that we can do. That means, for example, low energy requirements have relationship with autofocus. Okay, autofocus obviously needs energy rather than manual focus. Okay, or auto exposure, energy. High number of pixels, also energy. High number. So this is the relationship between these characteristics. Okay, and you give scoring. You give scoring for this relationship. Then from there, you compare with different company competitors. What is your are you better or poor, or so different companies have different way of evaluating. Some give scoring 5, 4, 3, 2, 1, or just give some indication whether we are doing better than competitor or not in terms of, for example, lightweight. Is our camera that we're going to produce using this material, is it going to be lighter than other brands, other companies producing similar cameras, for example? Okay. And to make things much a little bit more meaningful, then we put target values. So this is the technical attributes. So in terms of energy, electrical requirement 0.5 amperes. All these are actually technical requirements that is 2 is to infinity. And you evaluate in terms of competitor, whether what competitors are. For example, we use 0.5 ampere, but company A 0.7. So probably we are better. So us mean our company, right? So this is the very simplified version of the house of quality during design. Okay, during design we can do the translate customer requirements into technical requirements. Okay, so that we have a view of what is actually the customer actually wants. You can go for much more detail. This is a very simplified QFD, quality function deployment. Okay. I have a video on this. You can look at my YouTube channel. I have a video on quality function deployment. It's much more detailed than this. Okay. It is. I've Mimas. So I have this quality function deployment video using this slide. It's actually Nihon Kara yo. It is Hinshisu Kino Tenkai. And it was developed by Kano, okay. Not Kano, it was developed in Mitsubishi. So you can watch this video. I have much more detail on this. Okay, here. It was developed Mitsubishi Kobe Shipyard, 1972. Okay, and it is very powerful if it is done correctly. I just show you the this. So this is the much more complicated house of quality QFD for computer server. server, computer server. Of course, this is a bit old, but this is Sun, IBM, Hewlett Packard. So this is their customer needs. This is how, and this is competitor evaluation. And then you scoring. Okay, you can see the scoring down there if you can. So this is a full complete QFD. Okay. Right. I do not know whether this can be closed or not. It's could be. This Zoom is you're not seeing anything, right? Are you seeing the slide? You're not seeing anything. No. Share again. Okay. Okay. So the house of quality is actually they have sequence. Okay, they have sequence means this is in actual case we can cascade down. Cascade means you move from one stage to another stage, from design and then specific components, production process, because and quality plan. So this design become what for the second house. This specific component become the what's for the third house. Okay, this is the parts house of quality. This is the production process house of quality, and this is the quality plan house of quality. Okay, so it is deploy resources throughout the organization to respond to customer requirements. Okay, so it is part of our method of trying to translate customer requirements into the company, into the technical requirements. Okay, right. How do companies actually organize themselves for product development? Meaning, how is product development management? Traditionally, product development is the responsibility of certain departments, distinct departments. That means, for example, the R&D is responsible for product development. Then they will actually develop. For example, in service organization, probably okay, marketing and service design duties is the responsibility of that particular department. Of course, it is not really a good way because only one department or one or two departments. So it's difficult to foster or to have a forward thinking. Okay, it's very traditional. There is another way. This is the first method. The first type of organization. Second is the company have champion. Okay, that means product manager. Product manager drive the product through product development system and related organization. That means there is some person who is going to actually be responsible for managing the whole process of product development. Okay. So some car companies also use this method. Okay. They have project engineer. Okay. Project engineer or new car project engineer or manager. Now, another way is, the third way is team approach. Okay, team approach. That means it involves all departments. Cross-functional means there is people from quality control, there is people from production, from engineering, from process. So they call it product development teams. And they are going to also look into design for manufacturability, whether it is manufacturable. There are manufacturing problems or not, okay, during the design stage. I mean, you build quality during the design stage. And also they look for value engineering. Value engineering means whether the material that we use, is it meets the function or not? Can you use a different design? Can you use a different material to meet the function? Okay. And the other well known is Japanese whole organization. Whole organization, that means no, there is no organization division. Everybody is involved in the product development or product design. Okay, there is some explanation on manufacturability and value engineering. So when you talk about manufacturing and value engineering, we always try to think about how to reduce complexity of the product. Make it simple, because the simpler the product, but it meets the function, the easier to make it. Okay, if you make the product complicated, then it is much more difficult to produce, to do maintenance. So that's why the Japanese, they changed the philosophy of product. Air conditioners, easy to install, easy to repair, and easy to maintain, because it is from the product design stage. They think about the user. The user is not only the person using the product, but the user is also the maintenance engineer who are going to remove the parts and do the servicing. So servicing easy. So that is also user, because sometimes we think user is only the directly using it, but reduce complexity, reduce the environmental impact, and then additional standardization of components. That's why you need commonization. Commonization means the same component. Steering wheel for Toyota, same for all models. So they don't have to design a different steering wheel for different, the logo is the same. So standardization, low cost, cheaper, rather than having unique. Improvement of functional aspects. When you do value engineering, you Google value engineering, you will see so many ways of improving functional aspect of product. Improve design safety, improve maintainability. I mentioned just now already. Improve maintainability of the product, as well as robust design. There is a method called Taguchi methods. Robust design. Robust means the product can be used even at extreme conditions. We don't know how customers use a product. We don't know. So that's why you need to design robust into the product. For example, this is an example of value engineering. Value engineering, value is function over cost. Function over cost. Function. Okay, I hope you understand this drawing. This is actually a part here. This is another part. So this design is, this is a bolt, and you join this part with this part. This is $3.50. If we use this, if I use design one, so the purpose is just to join this part and this part to make this shape. Okay, to make this shape. So this method is, this is welding. This is rivet. Okay. So, but there's two components. One is this shape and one is this shape. You see the evolution. So rather than having this shape, you make it flat, straight, flat, and make this part and riveting only. No need welding. 80 cents. So it makes sense to do value engineering to reduce costs. Okay. So that's of course, not your job, the job of engineers. As managers, you need to know only. I mean, MBA, you are MBA, right? So you must understand that there are this kind of things that we think about. As engineers, we think about this. Okay, some of the issues for product design, because product design is very wide. Okay, there are so many aspects in product design. I mentioned just now that we need to have robust design, and today we talk about modular design. Modular means it's no more breaking parts into smaller parts, but it's modular. Okay, for example, in car assembly, this is the brake system, this is the engine, and so on. And we use a lot of computer-aided design and computer-aided manufacturing. VR technology, virtual reality means you can view the product when it is being developed. Okay, you have this VR viewer. Okay, value analysis similar to value engineering. Okay, you analyze whether it is of value or not. Okay, and then sustainability and life cycle assessment. Okay, I hope there is an explanation on it. Okay, there is robust design is so that small variations does not affect the product when you produce it, and it will result into lower cost and higher quality. Modular design, you design according to the segments, okay, segments of the product. Computer-aided design, there are many software, there are many tools. You've heard of AutoCAD, okay? Design, I can do the design on my computer laptop now, and I can send the design to China. Okay, the design, they will download it onto the machine. They can make it under computer numerical control. Computer numerical control. So the design is using computers to design product and prepare the engineering documentation. It's very short development time. Today is very fast. That's why you can see new telephones being developed, new products being developed constantly. Okay. And in today IR 4.0, okay, someone talk about 3D, not only modeling. We have 3D printing today. 3D printing, not only 3D, 3D printing. 3D printing. You can this is 3D printing. This is so-called 3D printing. You layer by layer you produce the product. And today there are examples of they are making construction 3D houses. Houses? They're making houses 3D. Okay, 3D printing. So this is part of design for manufacturing and assembly. Okay, it is actually, it's being widely, it's advanced already compared to 20 years ago. Okay, previously it was only in terms of experimental, but now it's being used widely. And you can pass the design through the internet. That's why I said just now you can send the design files, okay, your program to do the cutting or to do the machining, laser cutting, and you can actually share that with your manufacturer in China. Okay, I designed in Malaysia using CAD, computer-aided design, and I send my files to China, and they can download the file, and then they can do the cutting, can do the welding, and so on. Okay. So it is known as computer-aided manufacturing. So you use specialized computers and programs to control manufacturing equipment. And because it is driven by the CAD system, okay, computer-aided design system, right? And there's a lot of benefits on CAD/CAM. So the short form is CAD/CAM. CAD/CAM, okay? CAD, CAD/CAM. So you have product quality, high product quality, consistency. Same product you can produce because it is automation, and you can reduce costs, and you can use a lot of new range capabilities. Right. So VR is 3D model of product. You can see the VR, virtual reality, virtual reality. And people, you are younger generation, I think you are much more familiar to this, right? Because you play games, you can see the 3D. So it allows people to see the finished design before a physical model is built. Okay, physically you can see. Very effective in large scale design, such as plant layout. So when you don't have to make the factory first. You do the design software, see how product flow, and you can see the simulation. You can test, can put materials and can see. Just now we talked about this already, value analysis. And finally, sustainability and life cycle assessment. Today, sustainability means, especially in Sustainable Development Goals, okay? UN Sustainable Development Goals, SDG. I think there is eight, if I'm not mistaken. So sustainability means meeting the needs of the present without compromising the ability of the future. We design green products today. Products must be green. Green means sustainable. Green products. Green products does not damage environment. Green products uses recycled materials or uses, we call it a circular economy today. Circular economy. If you have heard of this, maybe, circular economy means produce, use, put back, and use it again. So we don't waste our resources, materials, from the trees that we cut down. We need to preserve our environment for the future generation. And they do this life cycle assessment. Okay, life cycle assessment is to evaluate whether the product is damaging to the environment or giving more benefit. So you do a life cycle assessment. Okay, we have time for this for another session next week that I will, we'll talk about it. So in the meantime, if you want to Google and look at, there's a lot of interesting things in the internet. Okay, there's a lot of you can see for yourself. Okay, you can what is a cat listen to okay system. Okay. Oh, you cannot see. Sorry. Can you see? Can you see just now? Can you see this?
Yes, I can see.
Yes.
Yes.
So there is a software called SolidWorks. 3D design. SolidWorks.
Ability to be able to sit down and draw something out at your desk, walk it over to Matt, have him draw it in SolidWorks, and then create that physical part by the time you get in the next morning is just really cool.
SolidWorks helps me with the process from idea to actual
this is
product,
CAD,
because
computer
it's not just a 3D
sorry, this is
program,
machining.
it's not just a CAM program, it's
CAM.
it's all one. it's
can
so
see the machine, they
smooth, no
download it.
changes.
Our
You
first
can-
hinge we ever manufactured was for a 69 Camaro. We decided to make a precision part with the use of
see, they
SolidWorks and
can actually
SolidWorks
make
Cam
it,
that would allow this hood to go to the same spot every time. This hinge was developed to not only solve a problem that we had with the way that
Can be quickly clicking on our
so this is
dimensions and
Cam,
actually applying
design,
where we're going to press a bearing,
software.
where a
Okay?
thread
So
point
this
is
is
going to be.
software.
So when we open
And
and
then you
close
then
that
download
hinge,
it onto the
it's going to
machine.
be right where it needs to have.
Download it on the
Without
machine.
knowledge-based machining,
And they can
bringing
actually
1,000
produce
parts
it.
in-house would
Okay?
be nearly
So it's-
impossible. You know, I'm not just learning SolidWorks Cam, it's learning me and the way that we do things here at Ring Brothers.
Right, okay.
a lot of the reasons
So I think it's already 11:30. Let me just, okay. Do you have any questions? Anything that you want to, or you're rushing for your next class?